Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 7 is about WAN concepts. So in this video we are looking at purposes, operations, and we're going to be looking at different types of WAN connectivity. So, first of all, what's the purpose of a WAN? Essentially, a WAN is a telecommunication network that spans a larger geographical area. Realistically, a WAN is a collection of LANs. We already know that one network cannot leave itself unless we're going through a layer 3 gateway. Well, those gateways are typically what builds our WANs. So we can look at a WAN as a network of networks per se. Normally the breakdown is LANs are small, WANs are larger geographical area. LANs are owned and managed by an organization, WANs typically are not. WANs are going to be managed by like an ISP, for example. WAN services are provided typically for a fee. Where a LAN, again, it's managed and owned by an individual or by a smaller company, so there's typically no fees associated with that LAN. LANs definitely have a much higher bandwidth availability because it's dealing with local resources. WAN offer both low to high speed connectivity. It really all depends on what you're willing to pay for. So there are two main types of WANs. Private WANs and public WANs. A private WAN is a connection that is dedicated to a single customer. A private WAN could be a guaranteed service agreement using an SLA. It will also ensure consistent bandwidth, no fluctuation, and it does provide a little bit better security. A public WAN connection is typically provided by an ISP or other telecom service provider, and they use the internet, for example. In this case, the service level agreement and the bandwidth will vary depending on the shared connection, and it's not guaranteed secure, and it's not guaranteed always available. So with the private WAN, an ISP could be the provider of the private WAN. It's not so common anymore, but I know 90s and early 2000s, ISPs would actually provide the infrastructure for a private WAN connection. However, with the exploding bandwidth of the internet, public WANs definitely have taken more precedence. We have a few different types of WAN topologies: point-to-point, hub and spoke, dual home, full mesh, partial mesh. And don't worry, we have a breakdown of all of these. And again, these are not all of the WAN topologies. These are just the most common. So a point-to-point literally is a point through the network, through the internet, to another point. The layer 2 technology, that cloud, is irrelevant because between these two devices, logically, it views it as a straight point-to-point connection. With a hub and spoke, we could have a hub that leads to individual spokes. And again, we could also think of this as a semi-multi-point. It does enable a single interface on the hub router to be shared with all of these spoke circuits. So on the hub, we have one connection, and spoke A, B, and C all share that one hub connection. And again, the layer 2, that cloud technology is irrelevant because the ISP is going to make it seem as if that cloud is completely transparent. We can have what's called a dual home topology. This offers a greater redundancy, load balancing, and distributed connectivity. While this is more expensive and it is definitely more difficult to implement, they are the preferred method. They do require additional configuration, and there is a lot more complexity to that configuration. However, at least with this type of dual homed design, if one network goes down or one hub goes down, there's always the backup connectivity. We have our full mesh and our partial mesh. A full mesh, everything connected to everyone else. Our partial mesh is most things are connected to one another. And again, normally our partial mesh is just a small segment of our full mesh, with at least all points being able to connect to one another for the most part. All of these basically go over through a carrier connection. So another aspect of WAN design is how the organization connects to the internet. All of these connections assume that there is some form of internet connectivity. Normally with that internet, we'll have to have some form of service level agreement with the service provider. The service provider will provide the SLA that outlines the scope and the expected service, reliability, availability of the service and connections. That way they know exactly what they're paying for. If you want greater reliability, you end up paying more for it. If you're okay with 8 hours of downtime a year, then that's what you pay for. If you need it down to 1 hour of downtime, then again, it's going to probably be an additional cost. The service provider may or may not be the actual carrier. The carrier will own and maintain the physical connections and the equipment between the customer and the provider. There is no guarantee that the provider and the carrier are the same individuals, because oftentimes the carriers may actually be a third-party company that lease their infrastructure to other providers. So single carrier connection is when an organization connects to that one service provider. Again, there will be an SLA that will be negotiated between the two that guarantees the certain level of site. We have a dual carrier, and that's where our connectivity is going through two different ISPs. That way, if one ISP goes down, we have a backup ISP. That way, we still have redundancy in our network design. All of this goes along with the idea known as evolving networks. So the issue is our networks are designed to grow and to scale. So normally there shouldn't be drastic changes in growth. However, sometimes there is. So when you're designing the network, there has to be that growth concept in mind. So the network must be able to meet the day-to-day operations and have a certain level of growth to the organization. The network designer and administrator needs to meet these challenges by looking at what's currently available, the budget, and what the business should be doing in the next 5 or 10 years. Lastly, the network can be optimized by using a variety of design techniques and looking at current and future architecture designs of the network. Cisco outlines the proper way to design a network, and they outline each of the steps to future-proof it, thus ensuring that your network will be able to survive even in the future. To illustrate the differences between the network sizes, we can also use a fictitious company. They're going to call it the Span Engineering, and as it grows from a small local business into a global enterprise. And we're going to see that throughout the next several slides. So here, originally, it will be a small office with very few employees. It has a modem with a broadband connectivity to the network. It's a small LAN using DSL. And then it grows into more of a campus network, or a CAN, with its own building with multiple floors with multiple networks. And it's funny that they use 3 separate routers instead of like a layer 3 switch. But I mean, again, Span has grown through a facility, and now they are looking at having its own building or campus network. As Span grows, we may actually have to have multiple offices and multiple locations. So we can have a internet WAN that meets our interconnectivity connections, and we have multiple branch offices that will connect through the internet to allow for connectivity between our central office and all of our regional and branch offices. If we are talking distributing the network even larger, we could do the same thing through different WAN connections, and we can have them linked back using VPNs or a site-to-site VPN. We've discussed VPNs in a later chapter as well. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.